This is Mrs. Appia with the answer key for the practice test for Module 3, Topic A. 9m, negative 5y. Those are like terms and they can be combined. In the next problem, 4h and 2h can be combined because they are like terms. Change subtraction to adding the opposite, plus negative 4m. Change subtraction to adding the opposite, plus negative 6m. These are like terms and they can be combined, plus negative 10m. You can also rewrite adding a negative using the rule of subtraction, 16h minus 10m. Either one of those would be an acceptable answer. In the next problem, we have three terms that are alike, 5r plus 12r minus 20r. 5r plus 12r is 17r. Change subtraction to adding the opposite, plus negative 20r. Combine these like terms and you get negative 3r plus 5. Next, use the distributive property to simplify. 3 times 4x is 12x, and 3 times 2 is 6. Those are unlike terms and cannot be combined. Next, distribute the negative 6 to the first and the second term. Negative 6 times negative 7m is positive 42m. Negative 6 times 3 is negative 18. You can rewrite adding a negative as simple subtraction, 42m minus 18. Either one of those answers would be acceptable. These are unlike terms, they cannot be combined. Next, add 5m plus 7 to the quantity 16m minus 9. 16m minus 9 plus 5m plus 7. Start by rewriting subtraction as adding the opposite. Now it is all addition and we can use any order, any grouping. 16m and 5m are like terms, so we will group them together. 16m plus 5m plus negative 9 plus 7. Combine your like terms, that gives us 21m. Combine these constants and that gives us plus negative 2. You can rewrite plus a negative as subtraction, 21m minus 2. Either one of those answers would be acceptable. Next, subtract 5m minus 7 from 16m minus 2. Notice the parentheses, so we do need to keep those as quantities. Subtracting from, so we're starting with 16m minus 2. And we are subtracting from that 5m minus 7. The first thing I want to do is change the subtraction to adding the opposite. So this is going to become plus negative 2. This is going to be adding the opposite, and this subtraction is going to be adding a negative 7. So now I have 16m plus negative 2 plus the opposite of 5m plus negative 7. Notice now the opposite of a sum. The opposite of a sum is the sum of its opposites. The opposite of the first term is 5m, and it will be negative. It's positive here, so the opposite is negative. The opposite of negative 7 is positive 7. So the opposite of the sum is the sum of the opposites. And then just bring down the rest of the problem, plus the negative 2 plus 16m. It is all addition now, so we can reorder and use any order, any grouping. Our like terms, we have 16m plus negative 5m. And we also have two constants, and I'm going to put them in the order of the positive first and the negative second. Combining our like terms, this gives us 11m plus 5. Which expressions are equivalent to 2 times the quantity 15y plus 30? Distribute the 2 to both terms. 2 times 15y is 30y. 2 times 30 is 60. So we want any expression that is equivalent to 30y plus 60. When we simplify a, that gives us 10 times 3y is 30y, and 10 times 6 is 60. 30y plus 60 is the same, so A is equivalent. B, these are like terms, so that's going to give us 30y plus 30. This one is not equivalent. 30y plus 60, C is equivalent. 15y plus 30 is not equivalent. This is all addition, so we can combine our like terms. 15y plus 15y is 30y, and 30 plus 30 is 60. And that is also equivalent. So 3 of the choices are equivalent. Next, write each expression as a product of two factors. Here you want to divide by the greatest common factor. The greatest common factor of 15 and 12 is 3. 3 times 5x is 15x. Bring up the subtraction sign. And 3 times 4 is 12. So the product of two factors. This is one of the factors, and this quantity is the other factor. 3 times the quantity, 5x minus 4, is equivalent to 15x minus 12. In the next problem, the greatest common factor is 2. 2 times 3x is 6x, and 2 times 4 is 8. So the two factors are 2 and 3x plus 4. 2 times the quantity, 3x plus 4. Continue simplifying. Notice that we have a fraction and a decimal, so you have to change one to the other. I know that the decimal for 1/2 is 0.5. So if I have 0.5m plus 0.4m equals 0.9m. Next, change subtraction to adding the opposite. A negative plus a negative, they get added together. So we have 2.75 plus 0.8. You want to make sure that you line up your decimals. 5, 5, 3. A negative plus a negative is another negative. So we have negative 3.55y. Next, notice that we have two different denominators, so we need to rewrite these fractions using the common denominator. Times 5 times 5 times 3 times 3. Add your fractions. That gives us 11/15, and bring along your variable. And the answer is 11/15m. Next, distribute 1/3 to both terms. 1/3 of 12x is 4x, and 1/3 of 15 is 5. Next, negative 1/2. Distribute to both terms. 1/2 of 9 is 4.5, or 4.5. And a negative and a positive is a negative. And 1/2 of 8m is 4m, and that will also be negative. You can also rewrite adding a negative as simple subtraction, and then the answer would be negative 4.5 minus 4m. Either one of those answers would be acceptable, and they are unlike terms, cannot be combined. Next, you want to rewrite this subtraction as adding the opposite. So that becomes plus negative 0.5. I'm going to use a 1/2 instead of 0.5. So this becomes 7½ plus negative 1/2 times the quantity 8 plus 2m. Remember to do this multiplication of 1/2, distributing it to both terms before you do this addition. The order of operation says that you must finish multiplication before you can do adding and subtracting. So we're going to distribute the negative 1/2 to the first and second term. I'm just going to bring down the 7½ Negative half times 8 is negative 4. Bring down the plus sign. Negative half of 2m. Half of 2m would be 1m. 1m is the same as m. And the negative times the positive is a negative. These are like terms and can be combined. This gives us 3½ And then you can rewrite plus a negative as simple subtraction, or you can leave it like that. Also, if there is a variable, or rather a term with a variable, it would go before the constant. So I'm actually going to reorder this as negative m plus 3½ Either one of those answers would be acceptable, but this is preferable. Next, which expressions are equivalent? You'll want to simplify each expression. Distribute the 4 to the first and the second term. 4 times 6x is 24x. 4 times 10 is 40. Next, 6 times 3x is 18x. 6 times 2 is 12. These terms can be combined, so this simplifies to 18x plus 24. Next, 6 times 4x is 24x. 2 times 20 is 40. And finally, 12x plus 12x is 24x plus 40. So we have 24x plus 40 for A, 24x plus 40 for C, 24x plus 40 for D. And then B has a different answer. So the expressions that are equivalent are A, C, and D. Next, which expressions are equivalent? Notice that B and C are already in simplest form. They have no like terms and cannot be combined. But for A, we can rewrite subtraction as adding the opposite. So this becomes 12x plus negative 0.4 times the quantity x plus 8. Before you do this addition, you need to do this multiplication. Distribute the negative 0.4 to both of those terms. So I'm going to bring down the 12x and the plus sign. Negative 4 times x is negative 0.4x. Bring down the plus sign, and negative 4 times 8. Negative 0.4 times 8. This simplifies to negative 3.2. And I'm just going to bring down the rest of the problem. Negative 0.4x and 12x. Notice that I have like terms. These can be combined. One is positive and one is negative, so you subtract. 12 take away 0.4. Take away, so we need a decimal there. When you subtract, you'll need to borrow from the 12. That gives us 11. 10 minus 4 is 6. And bring down the 11. And the 12 is positive, which is bigger, so that's a negative, or rather a positive. So this simplifies to 11.6 plus a negative 32, or 3.2, is the same as subtracting 3.2 using the rule of subtraction that says subtraction means add the opposite. Notice that the answer for A is the same as C. So the expressions here that are equivalent are A and C. Next, Fred buys 6 boxes each of Reese's Peanut Butter Cups and Jujubes. Write two different expressions that represent the total cost of the candy. Let R be the cost of a box of Reese's Peanut Butter Cups. J is the cost of a box of Jujubes. Use product as sum and sum as product. All right, so we know that he's buying 6 of each. So he's buying 6 boxes of Reese's, and we don't know the cost, so we let R be the cost. And we know he's buying 6 boxes of Jujubes, and we don't know the cost, so we let J be the cost of a box of Jujubes. To figure out the total cost of the candy, we want to use a product as a sum and a sum as a product. One of the ways is to figure out the cost of the Reese's plus the Jujubes and then multiply that by 6 boxes. The other way is to find the cost of the Reese's, which would be 6 times the cost of the Reese's. Then figure out the cost of the Jujubes, which would be 6 boxes times the cost of a box. Then add those together. Those are two different ways, the product as a sum and the sum as a product. Part B. Reese's cost $1.25. Jujubes cost $2. Use each of the above expressions and find the total cost. Show every step. Let's do the problem on the left first. Here we have 6 times R, and R is equal to $1.25, plus 6 times J, and J is equal to 2. 6 times $1.25 is $7.50. 6 times 2 is 12. Add that together for a total cost of $19.50. On the left, this is where we substitute 2 for the R. We substitute 1.25 for the cost of the Reese's, and we substitute 2 for the cost of the Jujubes. That's the cost of the candy for one person. Then we multiply that by 6 boxes. So adding the total cost of the candy, $1.25 plus 2 is $3.25. Then we multiply that by 6 boxes, and that gives us a total of $19.50. Next, explain how each expression describes the situation in a different way. Let's go back to the problem on the left. On the left, we multiply 6 boxes times the cost of a box of Reese's. Then multiply 6 boxes times the cost of a box of Jujubes. Finally, add the subtotals to find the total cost. So that's $6 times the cost of Reese's, or rather 6 boxes, then 6 boxes times $2 each. So that's $7.50 for the Reese's, $12 for the Jujubes, then we add it together. On the left side, here you add together the cost of the candy for one person. So it's $1.25 for their box of Reese's, $2 for their box of Jujubes, so $3.25 for the candy for one person. Then you multiply it by 6 to get the total cost. Add the cost of one box of Reese's to the cost of one box of Jujubes. Then multiply by 6 boxes. Next, Gina says the two expressions are equivalent. Is she correct? Prove your answer by showing your work. So we need to simplify both of these expressions. I'm going to start with the easier one and take half of the first term and half of the second term. Half of 10 is 5. Half of 10p is 5p. These are unlike terms and cannot be combined, so this is simplest form. For the next problem, I notice that I have subtracting 5, so I'm going to go ahead and change that to adding a negative. Next, I'm going to distribute the 1/4 to the first and the second term. 1/4 of 20p is 5p. 1/4 of 40 is 10. Bring down plus negative 5. These are like terms and can be combined. So we have a positive 10 and a negative 5. Since they are different signs, we subtract. 10 take away 5 is 5. We have more positives, so the answer for this part is positive. That gives us 5p plus 5. Notice that we have the same value, just in a different order. But because of the commutative property, we could rewrite this expression as 5p plus 5, proving that they are exactly equivalent. So is she correct? The answer is yes, and I have shown my work. Finally, simplify and show every step. The first thing that I want to do is I want to rewrite subtracting as adding the opposite. So this is going to become 14 plus negative 0.25 times the quantity 5 plus n plus negative 3n. According to the order of operations, I need to do this multiplication before I can do this adding and this adding. So my next step is to distribute the 0.25 to both of those terms. And remember that it is negative. So I'm going to bring down the 14 plus, and I need negative 0.25 times the first term, which is 5, plus negative 0.25 times the second term, which is n. Okay, so that's distributing to the first and the second term. Then I'm just going to bring down the plus negative 3n. Continuing, I'm going to simplify this. 14, I'm just going to bring that down. 0.25 times 5, now that's going to be a negative, 1.25 plus, and then this simplifies to negative 0.25n plus negative 3n. Then I look for like terms. Notice that I have these that are constants, and also I just noticed that if this was negative and this is positive, then this 1.25 should also be negative. So double check to make sure that you've got that right. So I'm going to combine these like terms. One is positive, one is negative, and that means that I subtract. So 14 minus 1.25. Borrow from the 14 and Borrow from the 10. 10 minus 5 is 5, 9 minus 2 is 7, 13 minus 1 is 12. 12.75. Also, notice that I had more positives with the 14, so that this term is positive. Plus. These can be combined. They're both negative, so they're going to be added together. 3 plus 0.25. So 3.00 plus 0.25 is 3.25. And a negative plus a negative is a negative. Remember, on the number line, you would be going left and then left again. So we have plus a negative 3.25. And then remember the variable. I can reorder that because it is addition and put the term with the variable first. So I have negative 3.25n plus 12.75. Those are unlike terms and cannot be combined. So that is your answer in simplest form. That concludes the practice test.